So you should see three pictures. What do you notice about these pictures? What do they have in common? What's different? Take a minute, pause the video, see what you think. Hopefully you'll realize that they are all symmetrical over the y-axis. Which means that if I were to fold my paper or my graph in half along the y-axis, the pictures would match up. For example, if this was the point 4, 0, this would be the point negative 4, 0. If this was the point 3, 3, this would be the point negative 3, 3. 3, 5, negative 3, 5. And these are all known as even functions because of their symmetry over the y-axis. Now you should see a new set of three graphs. Take a minute, see what you think here. Are these similar, different? How are they related to each other? Take a minute, pause the video, make some observations. Hopefully you notice here they are all symmetrical about the origin. Meaning if I turn my graph upside down, I'm going to see the same picture. So for example, if this is the point 1, negative 1, this is the point negative 1, 1. If this is the point 4, 3, this is the point negative 4, negative 3. 3, negative 5, negative 3, 5. And these are all known as odd functions because they have symmetry over the origin. Now, it's important to know that there's a difference between an odd function and an odd degree, or an even function and an even degree function. So let's take a look at two examples here. So here I have an x cubed. So this is an odd degree because it's cubic. But it is not symmetrical around the origin. If I take my picture and I turn it upside down, I do not see the same graph. So therefore, it is not an odd function. It is simply an odd degree. Over here in my second picture, I have an even degree because it's quadratic, or x squared. But if I were to fold this in half along the y-axis, my graph does not match up perfectly. Therefore, it is not an even function, it is just an even degree. So please be careful with the difference between an even degree and an even function. Odd degree and odd function. They are not the same thing. So how do I determine if something is even, odd, or neither? Because we have that option as well. If it doesn't have symmetry, in either case, it defaults to neither. So let's take a look at even functions. Even functions, as we said before, are symmetrical over the y-axis. So I'm going to take an example of y equals x squared plus 4. And my graph should be here. Okay, my graph's not going to show up, so I'm just going to sketch it. And if you type this into your calculator, you should see something that looks like that, okay? So this is my parabola. Does it have symmetry over the y-axis? Yes, so this is an even function. For odd functions, they're symmetrical about the origin. So the way to tell this is, can I flip it upside down and it looks the same? So here's my picture for x cubed minus x. If I take this picture and I rotate it upside down, it looks the same. So it's an odd function. So even function, we check for y-axis symmetry. Odd function, we check for origin symmetry. So let's take a look at the examples. Determine whether the following functions are odd, even, or neither. Justify your answers using the graph. So in A, if I take this picture here and I flip it upside down, if you flip your paper or you flip your computer upside down, do you see the same picture? So this is odd because it is symmetrical about the origin. So that is part A. For B, hopefully you should notice that there is symmetry along the y-axis. So this function is even because it is symmetrical over the y-axis. So all you are doing is checking for symmetry in order to show even, odd, or neither. My last graph doesn't have symmetry over the origin because if I flip it upside down, it's not going to be the same picture. It doesn't have symmetry over the y-axis because if I fold it in half or if I use my marker, it doesn't match up. So it is neither because there is no symmetry. So even is symmetry over the y-axis, odd is symmetry over the origin, and then otherwise it's neither. So all you're doing is checking for symmetry. Can I fold it in half? Can I flip it upside down? That tells you even, odd. Otherwise, we're going to say neither.